My name is Anjani. I go to Visadalago High School. I'm a rising junior, and the project that I am currently working on is the ball tracking robot. The major changes from last time to the robot are the sonar sensors, the Pi camera, the battery, and the breadboard. The Pi camera is able to identify the ball based on masking and contours and the hues of the robot and the hues of the ball. The sonar sensors are able to identify the distance from the sensor to an object based off of the signal that it outputs and receives. The battery pack is what powers the Raspberry Pi and allows everything else to function because of it. The breadboard was added because there wasn't enough GPIO pins on the Raspberry Pi to be able to power all of the individual mechanisms. So I had to use the breadboard to attach it, to wire all of the parts to make sure that they can all function properly. So this is my code. Here's the first part, which is just getting everything set up, setting output and input, setting GPIO pins, importing all the things, that sort of stuff. Setting the triggers to false. This is the function used for the sonar sensors to be able to calculate the distance. This is just setting up the motors, and these are all the functions for the motors for the different movements that it can make. This is the function for being able to track the red ball by drawing the contours around where the camera thinks the ball is. And this part is used for the video as well as just used in the rest of the code, which tells you like where it is in relative to the position of like the camera. So here you create the globe. This is the drive function that's used inside of the that's going to be used inside of the generate frames function, which is what will be showing the actual video and like camera of what you can see on the robot. And so this is the logic of the function. So if distance, this part checks if if anything is too close to the robot. But if it's the ball that's too close to the robot, then it'll stop. But if it's anything else, then it'll reverse. And if the ball is on the left of the, and if the ball was on the left, or like is on the left of the, or is on the right of the camera, then it'll turn right, and if it's on the left, then it'll turn left. And if the ball is found, what it'll do is it'll just go forward, and this is what sets flag to be either left or right. And then if flag is 0, it'll turn right, otherwise it'll turn left. And then if found, and if the ball is found, then it'll move forward. And if it's not in frame, then it'll turn. And then this is the generate frames where everything is used. And then this is all of the things for the video camera feed. So yeah. And this is that code that you saw earlier in action. So if the robot sees the ball, it'll start to move forward. And if it's within 20 centimeters of distance, it will stop. This is what the robot sees during when the code is run. The main issue that I kept running into was the inability to translate my ideas of how I wanted the robot to move into code. One of the things that I was able to achieve was to have the robot be able to move forward until it doesn't see the ball in frame, and then turn in the direction where it last saw it. Through research and instruction, I eventually was able to complete this. What comes next is my modifications, which what I'm planning to do is attaching a servo that'll allow the camera to turn in the direction of the ball where the robot last saw it, and then be able to move forward there.